This is Mr. Beck Does Your Homework, AP Physics, Homework 4.3, question number 4. This is a classic truck on the bridge problem. A bridge of length 62 meters and a mass 30,000 kilograms is supported at each end. A truck of mass 40,500 kilograms is located 30 meters from the left end. What is the force on the bridge at the left point of support? The acceleration of gravity is 9.8. So on this bridge, what I know is that the truck has a mass that's going to be a force of gravity straight down. The center of the bridge, now my truck happens to be really close to the center of the bridge, but the center of the bridge is where the mass of the bridge is going to feel a force of gravity. B is pushing up on the bridge, and A is also pushing up on the bridge. Now, I don't know A, I don't know B. The truck and the bridge are going to be easy to figure out. That's just going to be mass times gravity. So if I want to figure out A, what I do is I pick B as my pivot because I don't know what this force is and I don't care what this force is. So I pick the pivot where I don't know and I don't care. So that is going to be my pivot point, point B. So now I've got to look at everything counterclockwise. So I know that my torques that are counterclockwise are going to equal my torques that are clockwise. So around this point, this force of the bridge, well, if I think about this, the force on the bridge would be pulling down that way. So that's counterclockwise. So that's going to be the force of the bridge. The force of the truck, well, the truck would pull the bridge around that pivot point also counterclockwise. So the truck is also going to be counterclockwise force. And then A, if I think of where B is, A is pulling up. So that would cause the thing to twist this way. So that would be a clockwise force. So counterclockwise, I've got one RF sine theta. And another, so that's the truck, I've also got the bridge, which is going to have its RF sine theta. And that's going to equal the force from A and its RF sine theta. Now, for all of these, sine theta is going to be 90 degrees, 90 degrees, 90 degrees, so the sine of 90 is going to be 1, so I really don't care about sine theta in this case. So now let's talk about the truck. How far away is the truck from support B? Well, the total length is 62 meters. The truck is 30 meters from the right, so it must be 32 meters from the left. Again, the bridge is 62, the truck is 30 meters from the right. I want to know how far it is from B, because R is the distance from the pivot. So that's going to be 32. The force on the truck is going to be the mass times gravity, so that's going to be 40,500 times my gravitational acceleration of 9.8. So there's my truck. Now I need the bridge. Well, I'm going to put the whole mass of the bridge at the center of the bridge, and that's what I can do with this. So if I have a 62-meter long bridge, I'm going to say that all the mass is located at 31 meters. So that's going to be 31 meters. The mass of the bridge is 30,000 kilograms, so that's going to be 30,000. And then I'm going to need my gravity of 9.8 acceleration. So there's my mass times gravity, so that gives me a force. And that's going to all equal RF. So R is going to be the whole length of the bridge from B to A, because A is that far away from B. It's 62 meters times whatever the force is on column A, or by this A. So if that's what I'm looking for, I want the newtons of that force on the left side of the bridge. So again, I've got the truck at 32 meters away from B. I've got the center of the bridge at 31 meters away from B. And I've got the pivot A at 62 meters away from B. So B is my pivot. I'm going to measure everything from there. Now this is just a simple matter of math. Multiply all this, add them together, divide by 62, and you will get the force from support A.